Yo, what's up people, welcome back to the channel. I'm the Deathunter, and today I'll teach you how to create a database for your Apple Music library. So let's get straight into it. When you go to Apple Music, click File and then Library, Export Library, and you'll create an XML file of your Apple Music library. And eventually when you open it up, it should look like this. Fairly complex, but not so complex as you take the format into account. Okay, let's go to the Python code. So as we're working with XML here, we're gonna import xml.etree.elementary as et. That's the code or the library that's going to parse the XML for us later on. And then we're going to import SQLite3. So we're using the SQLite browser in this project, so you should download it beforehand and create a database. So call it whatever you want, and I already have it, so I'm just gonna do a demonstration here. Okay, as you have the import statements done, we're going to connect the project or the Python code to the database. So con equals SQLite3.connect and your database file name, and cur equals con.cursor. So the cursor in this case, or as we have turned it into a variable, is going to connect to the database server, and it's going to make changes and updates to the database that we have connected to. So it's really powerful. And now we're gonna make some tables. So before we actually get into making any tables, we're going to drop the former tables that we have created, or in other words, we're going to delete the former tables. And we're doing this because in this program, if you want to make any changes to the former tables you've created, you can only create new tables. So if we don't drop the existing tables, it'll be a lot of redundancy and probably some errors that will occur, so we don't want that. So we're going to drop off the tables before we even create the tables. So we're going to create the tables off scratch. And then let's move into creating the tables themselves. Create table artists. So ID is basically the name of the role, and it's going to be an integer. It's not going to be null, meaning that it cannot be blank, and it's going to be a primary key, which means that this will be the primary or the fundamental director of this role if other tables are trying to talk to it. And then auto increment means that the table or the program will assign values to it automatically. For example, the first value will have an ID of 1, the second 2, the third 3, and so on and so forth. And it's going to be unique, and it's quite self-explanatory, meaning that not two artists can have the same name. And when you go to the database browser for SQLite and create a table and add some rows to it, you can do the exact same thing, but we're working with Python here, so we'll give the dirty work to Python. And then create table genre, it's basically the same thing, and create table album. And notice here we have the role Artist.id, and we're going to call this a foreign key, meaning that this will connect to the primary key over here, but I'm going to discuss it later on in this video. And then we're going to create a table track. This is by far the most complex one. It includes the primary keys, the title, the album ID, which is a foreign key, a genre ID, another foreign key, and some more values including total time, file size, file format, rating, and play count. But these are not necessary because it's only solely attributed to the table of tracks. Now let's move on to creating the actual program. Okay, now that we have created our tables, we're going to add values to them, and the first step will be to parse our XML. So we're going to create an input here, which is not necessary, and if the length of the input is less than 1, then the file name will be library.xml. Okay, Before we parse through the XML, we're going to define a function called lookup, and this will basically look up the values we're trying to find, like all the child values we're trying to find, through this very complex and sophisticated XML code. But you don't need to worry about it because it's quite case specific, and it's not very important. And then we're gonna parse the XML itself by defining a variable called stuff. Stuff equals et.parse, so that's basically the line that will parse the XML. And then all equals stub.find_all dictionary because there are obviously three nested dictionaries, or like 3 layers of nested dictionaries in this XML code, and we're only trying to extract this, like the innermost dictionary, which contains all of the information of the songs. And then we're going to create a for loop, so for entry in all. Before we're going to extract the information, we're doing a sanity check, and a sanity check is basically if any of the values we're looking for is missing, the program isn't going to crash. So if the track ID attribute or value is missing, normally the program will crash because it's an error, obviously, but we're telling it to continue so it doesn't crash. And so we're gonna look up all of the values that we want. Notice here under genre we're adding an if statement. So if genre is none, then genre equals to NA. So the case is, if some of the values listed here are not present, then the song just won't show up. Like, I don't know how to explain it, but that's just the sad truth. So we're trying to assign values to it if some of the values are not. And then as we have extracted all of the information or values that we want from the XML code, we're going to do another sanity check. So if name is none, or artist is none, or album is none, or genre is none, we're going to continue in case any of the values here are missing. We don't want our program to crash. And then we're going to create some output. So we're going to print the name, artist, album, genre count, file size, file format, rating, length, in that order, each time we pass through the loop. So we're going to get a very long output out of the Python program, but it's okay because it looks cool and you can show off in front of friends. Okay, that's it for extracting the information, and then we're going to actually insert the values into the database. Okay, now that we have extracted all of the information that we want from the XML, we're going to insert the information now into the tables we have created in our database. Okay, so the first step will be cur.execute insert or ignore into artists. So here is the table name, and here will be the element or row name. Okay, values, and here you'll notice that there is a question mark, which may seem very questionable, but here it's called a placeholder, so it's holding the place, a blank space for the values we're going to assign to it later. And now artist, so essentially we're just assigning the artist value to the artist column here. Okay, and then cur.execute select ID from artist where name equals placeholder and then artist comma space. So this line will essentially auto increment or assign an auto-generated and incremented value to the artist ID column that we have earlier named. And then here we're creating a variable called artist ID for later use for the foreign keys that we're going to use later. So here cur.fetch1, so this function will fetch the following one line of the information that we got. But as we loop through this whole thing multiple times, it'll eventually get all of the information. And then cur.execute is basically the same thing for genre, and then it's also the same thing for what is it? Yeah, album. And then here comes the fun and intriguing and sophisticated part. So cur.execute insert or replace into track. So insert or replace will turn into an update if the unique attribute is violated. But here it's not really necessary because sometimes tracks will be repetitive if you have downloaded tracks from different sources, for example, off YouTube and off Apple Music or off Spotify, and you compile them all into your Apple Music library. So here we didn't assign the unique value to the name of the songs. So here it's not really necessary, but if you're only doing it with Apple Music, then you might find it necessary just to make the process a little cleaner and easier to track. Okay, and we're assigning all of these values to the tables. This is no jokes here. And notice that we have a lot of placeholders. And one thing to be careful with is that the number of placeholders must match the number of values you're assigning. So right here we have 1, 2, 3, 4, 5, 6, 7, 8 placeholders for 8 values. So that's correct. And then we're basically assigning all the values to this track table. And then last but not least, in the code, we'll say con.commit. And this will commit all of the changes and updates that we have made to the database. Now that we have finished the code and successfully inserted all of the values, it's time to see the results. And we're just, let's terminate this program, clear, and run this program again, enter. And you'll see all of the things now here listed. Yeah, there's a lot. You can see we have found 437 songs, which is kind of a lot. But the magic here comes is that we'll actually see the things that we have inserted here in this database. So I'm going to open up my database file, which is, wait, what is it? Tracks, yeah, it's this one. And as you open it up with this, you'll see all of these things show up. Like we have 5 tables here: album, artist, genre, track, just like what we've done here. And you can see all of the rows here. Okay, browse data, that's where you'll see all of the data. And here's all of the albums that we found. We've extracted all of the Apple Music library and artist. Where is it? Artist. Yes, so many. Okay, and then genre. So you can see all of the IDs are also incremented, but it's not 1, 2, 3, 4, 5 because we have auto incremented like other aspects of this database, and it's doing so to avoid repetitiveness or redundancy. And then track, just a lot of tracks, yeah. And you can see all the values will match with the XML, so it's quite special. And here we have all these filters, and let's see, we wanna hear some Senori. Oh, actually not. I don't know. You can search the songs here, and Album.id, Genre.id, total time, file size, bytes, file format, all of these things. And you may ask, why are we not directly using the album names and genre IDs and total time and file size, like these things? Like, why are we using numbers instead of like full strings? That's because when you're working with an especially large database, if you're going to be a data scientist, then these things like strings will effectively and largely increase the size and processing pressure of your program. And if we're using foreign keys, using numbers, then it's going to run a lot faster. But you may wonder, like, how do I know like which album is this? How do I know which genre is this song? Something just like this. Well, you may think, well, then I have to go to genre and pair like each of them and see the numbers if they match. But that's when some more SQL code comes in handy. So I have this this thing here. So this SQL code, you can just copy it. But here we have some join statements and some on statements here. You don't have to worry too much about it. I'll talk about it later in another video. But as we run this code, we see all of these things. So title is something just like this. Name, name of the artists, the Chainsmokers, the title of the albums, Memories Do Not Open, name, I don't know what this is, but NA. Wait, yeah, so this is the genre. Yeah. And file format, file size bytes, play count, total time, all of these things. You can do it via SQL. So it's quite magical. But I guess that's the end of the video. It's been quite long. Consider subscribing and liking this video. And if you have any questions, just comment below and I will be sure to reply. And thank you very much.